And so that brings me, after completing the square, to determining max and minimum of a quadratic function. So what you're going to learn is all quadratics, such as this one, either face up, and their vertex is there, or if there's a minus up front, they face down with the vertex there. That would mean if they face down, this is a maximum, and if they face up, it would be a minimum. So we have to learn how to complete the square to find the vertex, and often we're giving it in standard format. So this is going to be about how to figure that out using completing the square. And I'd like you to preferably watch the last video I did. But what about when they give it in a factored format? How do I complete the square when they give it in a factored format? Suppose they give me this as a riddle of some kind, doesn't matter what the riddle is, and they tell me to figure out the max value. Well, the nice thing about this is this minus 5 will also be in front of the vertex format. This goes through 10, 0 and minus 2, 0, which means halfway through will be the vertex, or the axis of symmetry. Since minus 2, we're going to add 10 plus minus 2, you get 8 divided by 4. That's how you figure out the distance between any 2 points. You add them and divide by 2, add them and divide by 2. So we get 4. And when I plug 4 into this equation, I get minus 6 times plus 6, which is minus 36, minus 32, minus 36, sorry, and then times minus 5, it becomes plus 180, which means the vertex of this will exist at 4, 180, and it will face downwards because of this minus 5. And I can even write it in vertex format automatically with that information. And this will be the same graph as the above. That saves a lot of time then trying to expand this first and then complete the square. Let's continue. You'll find ones with decimals. Sometimes it's just easier to multiply by 10 if you're trying to factor them. But if you're going to try to complete the square, sometimes people find it difficult. So I might as well take that slightly more difficult. I'm assuming you watched the complete the square video. So my first goal is always to realize that I don't want any number in front of the x squared. My second goal is to realize that this number right now is inconsequential. So I'm just going to move it aside. I call it Larry. But if I want x squared out of there, I need to divide both of them by 1.8. Now obviously you don't want to torture yourself endlessly with divisions. So 14.4 divided by 1.8 is this. And in these problems they often give you a clean answer, as they did, 8. So that means if I factor out 1.8 from this, I get x squared minus 8. Now I'm assuming you watched the last video, and by the way it's minus 8x, sorry. And right away I'll realize that the perfect square for this is x squared minus 4, but that it creates an so it'll be like that. And it creates exactly what I want, which is x squared minus 8x. However, it also creates this unnecessary plus 18. So if I want to get rid of this or replace this with exactly as written as a complete the square, I can't put this in because I'll create this, but I can put it in if I also subtract 16. In other words, if I rewrite this here as, okay, this is what I want to replace. This is a suitable replacement, but if it spits out this, I want to get rid of that 16. So now I can replace all of this right here with a bracket x minus 4 squared minus 16, but it's got to be in its own unique bracket as well. And that's because I'm not done with it yet. I now must get that minus 16 out of the bracket by multiplying it by 1.1. 1.8 rather. And I get that. So that means to get it out of the bracket, it's going to look like this. However, I also want to add it to that other number. And I get a final numerical result outside of the bracket of this. Which means I can replace all of the above pretty much like that. So again, the steps were factor out the 1.8, discover that it was x squared plus 8x, figure out the perfect square that will create that, and then subtract also the number that is not what we want out of it. That way when this expands, I get rid of the 16 that it creates, then multiply it by the 1.8 and add it to that. And that's the final result, which means I have a vertex here of 4, 127.7, and because it's positive leading coefficient, it's facing up. Let's see if I came close to that. Let's see if they actually, yeah, there we go. Don't know if I still have it. Yeah, 127.7. So here they have it here. Right there. And they did it, they probably, well, they used a graphing calculator, so you could just throw it into Desmos. And then they have a demand function. So demand is usually based on a price and how many you're going to sell. And then the cost is usually how much it costs you to produce it. And profit is always going to be equal to revenue minus cost. And I think, yeah, so they're calling this revenue, I believe. Oh yeah, they're just calling it demand. So you'd always have to multiply your demand by the number of units you are selling, which is usually X. And that will be revenue. So revenue is always demand times the number of products, and it's explained over here. And profit is always going to be your revenue minus your cost. So they essentially expand one and they subtract another to come up with a quadratic. And then here they're solving it factored wise. So that means the axis of symmetry will be at x is equal to 3. Which they figure out there. And then they plug it into the formula to figure out the max height, which means the max profit you could obtain from this is $6,000. So you're going to get a lot of max profits. But this is all about completing the square. So we're going to check our understanding. Which of the following quadratics has a maximum value? Anything that's downward facing, that's going to have a max. That's not. That's going to have a max. And that's not. State the vertex of each parabola, indicate max or minimum. So this one's a max, and this one's a min, and the parabola here is minus 5, minus 2. And the max over here is 4, 8. And this one. And continuing on, determine the max or min of each. When it's in vertex format, you can figure it out. When it's in factored format, you have to figure out where the axis of symmetry is. And always keep in mind that y is as what you see is what you get, but x is the opposite. Also keep in mind when there's nothing there, it's plus 0. And this is a factored format, and this you might think is a factored format or something unique, but that's really an x plus 0, so that means the x value for the vertex is at 0. So stating these in order, A is minus 1, comma 6, so it's opposite for x. B is 5, comma 0. C, we only know that it goes through 0, comma 0 and 4, comma 0, which means x is equal to 2 is the axis of symmetry, which means if I put 2 into there, I get minus 4 times minus 2, which is plus 8, which means the vertex is at 2, comma 8. And it's facing down, so it's a max. This is a facing down, so it's a max. This is facing up, so it's a min. And then finally the last one is facing up, and it is 0, comma minus 7. Because there's no other x value in here, so this is technically a vertex format. It's sometimes hard to spot, so I'll show you the difference. You see how these all have x's in them as well as x squareds? That's a standard format. We have to complete the square to figure it out. But so you can see this one has an x and an x there. That's a factored format. And actually it's not a properly factored format because this plus 5's out of the blue. But there's a vertex format. So they're all subtly different. This is nothing really. Determine the max or the min value. So it's, use at least two methods. So you can see that these are all, let's get rid of all these. So you can see that these are all different completing of the squares. Okay, so for this one, you'd have to complete the square. So first off, move the number way off to the right. Second, see if you can figure out what completing the square that would produce that. I can see that it would be x minus 2 squared would produce an x squared minus 4x plus 4, like this. Which means to get this part of it, I have to subtract 4. So if I replace this with that, that will produce this. I don't want the 4, so I have to subtract 4. So I'm going to replace that up above with this, which immediately tells me that's the vertex, and there's no other numbers to fiddle with. Since this is a positive leading coefficient, it's a max. Sorry, it's a min. And the vertex is 2, comma minus 1. Same method for most of these. So if I look at this, yeah, I can borrow from the 12 sometimes, and it's not a bad idea to borrow from the 12. So if I look at this, I'll do it a different method for you. I can see that if I divide the 8 by 2, this is going to be the perfect square. But it's going to produce x squared, which is what I want, minus 8x, which is what I want, but it's going to produce a 16 I don't want, right? So if I'm going to replace this with this, I have to subtract 16. So I'm going to replace this here. And I would have to subtract 16 to do it. That way, when this expands and I subtract the 16, I'll be left with that, which is what I want. Now when I take minus 16 and I add 12 to it, I get minus 4. Which means the vertex of this, which is a min value, is 4, comma minus 4. On to the next one. This might not look it, but it's indeed a standard format, and the first thing I have to do is I never want a number in front of my x squared, which means I have to factor a 2 out, which is too bad because it would have been easier. If I take a 2 out of both, which means just divide both by 2, I get this. I can see that the perfect square is going to be x plus 3 squared, which will produce what I want, and also produce something I don't want. Like that. So that means if I want to replace this With that, which will expand to this, and I just want this portion of it, I have to subtract 9. So I have to take, if you want to look at it this way, I'm going to subtract 9 from the right side. So, right, like this. And when I subtract 9 from both sides here, it goes to this side as a minus 9. And you can now see that this is what I have here. So I need to replace it with this. So I'm going to do that. The problem is you might be tempted to stop there, but when I factored out the 2 and started fiddling with the numbers in here, this minus 9 is tied in with other stuff, but I want it out of the bracket. So to do that, I have to multiply it by 2. And that's the only oddity when you have a number in front of the x squared. Whatever number you end up subtracting, you have to get it out of the bracket when you're done. So the actual vertex here is not minus 9, it's minus 18. So it means my vertex, which is a min because it's facing upwards, is minus 3, comma, minus 18. There you go. And I'm just going to finish D, put it on pause, I just have to do something. So this is facing down, so it's going to be a max. Put the 15 aside, like that. We're going to factor out the minus 3. And you get x squared minus 12x. No, sorry, minus 4x. And you also have to keep in mind that essentially when you factor out the minus 3, we're creating this massive thing here. And the plus 15 is on the outside, like that. And there's a squared there. Which means the perfect square of this is this. And if I expand that, I would get this. And if I subtract 4 from both sides, I get this. So when I subtract 4 from both sides, this 4 essentially moves to the other side of the equation. And now I can see I can now replace this with that. But as I said, I have a little problem with that giant bracket because I factored out a 3. To get it out of the bracket, I must multiply that minus 4 by minus 3, and it comes out of the bracket as plus 12. But I do effectively get rid of it and the brackets when I do that, which leaves me with most of what I want. But outside I can see I don't want plus 12, I just want one number, plus 12 plus 15 plus 27. Which tells me, especially when I put the proper bracket back, that the vertex of this is plus 2, comma 27. And it's a min because it's facing, or sorry, it's a max because it's facing downwards. This one already has the vertex. No, it doesn't. It's being tricky. They tried to sneak it in, but I can see an X there. So this is gobbledygook. It's not standard, it's not factored, it's not anything. So you have to expand it to even get anywhere. You get 3x squared minus 6x plus 5, like that. Now I would have to factor, I can move my 5 to the side. I could factor out a 3 here. You get 3. X squared minus 2x, like that. Now I just need to figure out what the perfect square is to make this. And it's clear it is going to be this. X minus 1 squared is going to be x squared minus 2x plus 1, like that. If I just want to get that part all alone on the right side, I'm going to subtract 1 from both sides. It's going to move to the other side and become a negative 1. So that means I can replace this with all of this. However, remember I factored out a 3. It's not quite done. And I also have this plus 5 hanging out. Ooh. And technically, when I did that, I should have put a big old giant bracket. So 3 times the minus 1, minus 3, plus 5, it's all plus 2 on the outside. Which means, since I have a plus coefficient, my vertex is 1, 2. And finally, this last one is already in vertex format. It's the only one that is. It's facing downwards with that minus coefficient. And there's the vertex, and it's a max. Alright, I'll talk more in a bit. Okay, we're going to continue with this here. And it is, each function is the demand function of some item, where x is the number of items sold in thousands. Determine the revenue function, the maximum revenue in $1,000. So when you don't have cost, revenue is going to be equal to the command function times the items. Sorry, the demand function. So it's going to be, that's going to be the demand. So in this case, we have the first one is a minus x plus 5. And so when we multiply that by x, we get x squared plus 5x. Now, the problem with that is you've got a minus in front of your x squared. So you have to take a minus 1 out, so it's a downward facing parabola, and you're left with this. And the secret to finding any perfect square is having that first number. So if I look at it this way, I'm just going to bring this down a bit. Here we go. So you get 5x plus 5 over 2 is the perfect square of x squared plus 5x. And if I expand that, I get x squared plus 5x plus 25 over 4. Close enough. And you got to remember these are just fractions here. And if I'm just trying to get this part alone, right here, I subtract that from it. So I get this. And I change that to a minus. I get that. Which means I can replace this portion up here with this. And there you go, that's pretty much it. And I got to put a bracket around it. And to get rid of this, away from the minus 1, I have to expel it. So when it gets booted out, it becomes that. And there we go. So that gives me a vertex of minus 5 over 2 thousands of products. So that would be 2,500 minus 2,500 products. Oh, sorry, yeah. I forgot when I ticked this minus 1 out, it actually became a negative. Like that. Which means this down here is not a negative. And I was clued into that because I can't have negative products sold. So I can tell you now that the vertex is this over this, which is essentially 2.5 over 6.25, which means I sell 2,500 products for a maximum of $6,250. And it's a downwards facing parabola. And they'll all be like that. So you just essentially multiply all the command functions by x. So when I multiply this by x, I get 4x squared plus 12x, so that's now revenue because there's no cost. when I take minus 4 out of it, I'm left with x squared minus 3x. And if I'm going to find the perfect square of this portion of it here, I half that 3, x minus 3 over 2 squared. But I know if I expand that, I get x squared minus 3x plus 9 over 4, like that. Which means if I want to isolate just this part of it, I have to subtract 9 over 4 from both sides. Goes to this side and becomes a negative, which means I can replace everything up here inside a bracket, a giant bracket like that, with this. And to get the 9 over 4 out, I have to multiply it by the minus 4. The 4's will cancel out, and I'll be left outside with a plus 9. Now I can get rid of all the brackets. Which means I have a maximum value of a vertex that's a max value of 3 over 2, which is 1.5, comma 9, which means I have to sell $1,500 products to make $9,000. You can also you can figure out how to graph it as well, because this is a vertical stretch of 4, a reflection in the x-axis, shifted up by 9, and all the x values are pushed to the right by 3 over half rather. This one, it's the same process. Just might be difficult to figure out how to factor out 0.6, negative 0.6, but all you do is you divide both of them by negative 0.6. So this gets factored out. Oh, first you multiply by x squared, and you get this. And then you got to factor out this part of it to get the x squared all alone. And this divided by 0.6 is probably something like, oh, I don't know, 30? 25. So this becomes plus 25x like that, and like that. And to figure out the perfect square of x squared plus 25, I take the half of the 25, which is 25 over 2. And if I expand that, it becomes x squared plus 25x plus, oh, that's a tough one, eh? 25 over 2, 25 times 25. Becomes 625 over 4. And if I want to just put that into actual values, 625 divided by 4 is actually that. So I could just replace that whole thing with that. Which means if I want to get this, and by the way, there's a square here and a square here, which means if I want to isolate that one part of it, and by the way, this is a fraction here, then I just subtract this from both sides, moves over here, and becomes a minus, which means I can replace this up here in this bracket with this. There we go. But I have to multiply this negative 156.25 by 0.6 to get it out of the bracket. It's going to become positive 93.75. So this is what I'm left with. And that's not an x squared, by the way. That should be x plus 25 over 2. And by the way, it's going to be minus, because I forgot again to change the sign of it. And I think I said minus 2.75. And that's what I'm left over, which means the vertex is 12.5 or 12,500 or 12,500 products sold to make $92,750. This as well, multiply by x. See that they're all the same process. When I multiply by x, I get x squared here and an x there. When I take the negative 1.2 out of it, I'll try to get the signs correct this time. I get that, and that goes in there 4 times. So I get minus 4. Minus 1.2. X squared minus x squared minus 4. Like that. 4x rather. There we go. Finally got it right, which means the perfect square of this is x minus 2, which expands to x squared minus 4x, which is what I want, plus 4. If I want to get the plus 4 to the other side, I subtract 4 from both sides, which means that if I want to get x squared minus 4x to match in a perfect square, this is what it is. However, I need to get that minus 4 out of the bracket, so I need to multiply by negative 1.2, and it of course becomes back to what it was, plus 4.8, and I can get rid of all my brackets now in this number because I've multiplied it. Eek. There we go. Which means my vertex is 2,000 items sold, and I believe that's going to be actually, yeah, and $4,800. And using graphing technology, so for this you either learn your graph or you just put it into Desmos. This one's going to be a lot easier than it looks like. It looks like it comes out to 1.5, negative 1.5. But I'll just let you do that. That's just graphing, with letting computers graph it for you. Okay, moving on. Often you'll get balls thrown. In this case, this is thrown from a rooftop, which means it started at a height above the ground. So you won't find this ground spot equal to the throw spot. However, you can find the height of the rooftop immediately, because if we look, this is the x-axis, will always almost be time, and the y-axis will always be height. And that means that if I put in 0, that means this beginning spot right here is 0, 0, and the before does not matter. So this is the domain, and this is the range. Sorry, that's the domain, and that's the range, that's the domain. Which means at 0 time, that's the height of the building. If I put in 0 time into this equation, I can see right away the height of the building is right there. So that's the nice thing about the standard format is you can see the y-intercept right away. So you know that the height of the building's right there, and the max height of the ball will be somewhere up here. To determine max height, you have a choice. You can either figure out the y-x-intercepts and determine the axis of symmetry, which in my opinion is quite long. How long is when height is 0? You can actually figure that out right away. And how high is the rooftop? So the rooftop is at time 0, so we figured C out first, and you often find these questions are in mixed order, and I actually prefer to answer them in reverse order depending on how easy they are. Obviously it helps to map out situations, so the only thing we don't know is time here. We do know it'll be matched on this side in negative time, and it'll be halfway in between will be the axis of symmetry. So there's several things you can do. Now the first thing I would suggest is always look for numbers that can be factored out, because it can make your item much easier to see and understand and factor. So when I do this, even before I go into the vertex, I can immediately see the factors here are um, mine. Let's see. Are there easy to find factors here? Probably not. It looks like it's going to be, it's not minus 5 and 2. Plus 5, minus 5, plus, no. So they're not easy to find. So we'd have to use a quadratic formula to find that. Let's see if I got that right. 10 and 1 doesn't work. So that usually I'll be able to find this. However, if I set this to equal to 0, I can answer part B. So if I do that, I get part B, divide by 5, get nothing. And the question is, when will this, actually, you know what? Let's complete the square. Usually if I factor this, I like to figure out where the ball lands. But let's complete the square instead. So if I'm going to complete the square, I'm only going to take the minus 5 out of the first two items. And I'm going to leave the 50 all alone on the side. And keep in mind that's squared. And immediately I can look at that and say, okay, my completion of the square is t minus 2. And I automatically know that, because 2 minus 2 squared is going to be equal to t squared minus 4t. And then plus 4, like this. And pardon the t2, it should be t squared, like that. Now, obviously, if I just want this part of it, I'm going to subtract 4 from both sides, and I'll get this. And when I subtract 4 from the right side, it disappears. Since I have this right there, I can replace it with this, but keep in mind, I have to put it all in a bracket. So that means I can replace all of that with this. And it's clear I want to get the minus 4 out of there by multiplying by minus 5, and it'll become plus 20 out here. And it's clear when I do that, it's 20 plus 20 plus 50. By the way, you always have to clear, when there's a number that you factored out, you always have to clear out this number by multiplying by that number to get it out here with this number to add to it. So minus 5 times minus 4 is plus 20, and plus 20 plus 50 is plus 70, which means I can replace this and this and this with plus 70. Right away I can see the vertex, and I can also say that this is a downward facing parabola because of the minus 5. The vertex is going to be at 2 seconds. It's going to reach a max height of 70 meters. So that tells me this. Comma 70. Now I've answered A. 70 meters is the max height. To answer the last part, you set this. When's the ball hit the ground? When the height is 0. So if you set this to equal to 0, that's what you do. Now to unravel any equation, you have to go in reverse bed mass order. So I can see there's an exponent, so that's the last thing I'm going to do. There's a bracket, so that's the second last thing I'm going to do. There's a multiplication, so that's the third last thing I'm going to do, and this is the first thing I'm going to do. Subtract 70 from both sides. When I subtract 70 from the left side, the 70 disappears. When I subtract 70 from the right side, it becomes minus 70. Essentially, it moves to the other side of the equation as the opposite. Then I'm going to get rid of this minus 5. Now I want you to get in the habit of multiplying by the reciprocal to get rid of something. So I'm going to multiply it by minus 1 over 5. It's going to cancel out, which means the left side. And the reason I do this is because I want you to get used to doing it, because you're going to be dealing with fractions sometimes. And it's much easier to do this to get rid of fractions. So I get minus times a minus. It's going to become a plus, and divided by 5. I get, let's see, 12 is 60, so 14 is 70. So I get plus 14. And the minus 5 on the left disappears, because when I multiply by the reciprocal, it disappears. We've essentially gotten rid of these brackets. What's the last thing to do? We have to take a square root. of both sides. Now, the square root will actually give you, when I take the square root of the left side, the square disappears, and the square root of the right side means I have to add a plus and a minus. I have to do this because if for instance it was the square root of 4, the square root of 4 has a plus 2 answer and a minus 2 answer. Minus 2 squared is 4, plus 2 squared is 4. So that means plus of this squared is this, minus of this squared will be this. And that explains why there's this minus time over here. The square root of 14, by the way, is somewhere between 3 and 4, and it's closer to 4, because 3 squared is 9, and 4 squared is 16, which is higher than 14. So we're talking about 3.7 seconds. We'll put it in the Desmos to see exactly, or we can take the square root, but we're not quite done yet. We have t minus 2, which means I have to add 2 to both sides. And finally, I get t is equal to, and you really want to put the plus minus after the 2, so you do plus minus square root of 14, which means I'm going to take 2 seconds and subtract roughly 3.7 to get this one, and I'm going to get 2 seconds, and I'm going to add roughly 3.7 seconds to this one. So this is going to be roughly 5.7 seconds. To find out exactly, since they do want an exact time, by the way, square root 14 is much more exact than anything I can put in the calculator. But if I do 2 plus square root of 14, there's the square root of 14, 3.7 as I suspected. It's 5.7. So this is the time. And sometimes your teacher will say, to 2 decimals or two significant numbers, and to 2 significant numbers would be this. There's 2 numbers that are significant. So it takes the ball to, at what time, how long does it take the ball to reach max? Oh, it didn't even ask that. So it takes the ball 2 seconds. But I've just given you a way to figure out when it hits the ground as well. You might ask yourself, what about the minus version? And 2 minus the square root of 14 gives me a negative situation that doesn't exist because we don't really have negative time. However, it is right over here. That's when it starts off at the ground. But because we started off at the roof, that spot exists well before time starts. So we ignore it. But it's why this has a plus and a minus. So anyway, I didn't even read it properly, which is another thing you should always do. Make sure you read your questions. How long does it take to reach the maximum height? 2 seconds. How high is the rooftop? 50 meters. What's the maximum height? 70 meters. But it was good to do the other question because that'll come up as well. Here's a cost function. Cost function is just how much will it cost you to manufacture something, and it's usually a negative value. In this case, it's a positive value, so we have an upward facing parabola, and that's because they're looking for the minimum product cost, which means if you think about it, they're looking for the vertex. So we're going to complete the square. We're going to move the number to the side, and we're going to divide both of these by 0.28. That's how you factor out 0.28. The first one will just disappear, but 0.7 divided by 0.28 will be 2.5. So we're going to get this situation. And there's going to be an x here as well. And this is still going to be there. It's just not something we consider right now. Now, the tough part here is to say, what is half of that? What is half of that? Well, half of 2.5, you can either leave it as a fraction, and if you don't like that decimal, you can multiply them both by 10. 25 divided by 5 is the fraction, but I can see I can divide them both by, what did I do there? I multiplied top. I had 2.5 up here. And I know half of 2.5 is divided by 2, but I multiplied both by 10, top and bottom, which does not change the fraction. I get 25 over 20. This can be divided by 5, so can this, so I get 5 over 4. So that means this fraction is half of 2.5. So that's one way you can do it. You can also just take the number half of 2.5 in your calculator is 1.25. So I'll do it both ways. So here's 0.28, which means the perfect square for this is that. However, I have to figure out what number I have to subtract to get rid of it, and I also have to put a big bracket here. And I can tell you the number we're going to end up subtracting is the square of 1.25. But let's do it algebraically to show it. If this is the perfect square that I'm looking for, and I square it, I get x squared minus 2.5x. Go ahead and try that if you don't believe me. And I end up with also plus 1.25 squared. Plus that. However, all I'm interested in getting is this. So I have to subtract it from both sides. I have to subtract that 1.5625 from both sides. So I move this aside, and I subtract it from both sides. So now I get this. Which means this here, and I forgot the square on this side, is equal to this here. So I can replace all of that with this. And then the only other thing I got to remember is that there's this plus 1 hanging out over and over again. Now, to get that out of the brackets, I have to multiply it by 0.28. Fortunately, it's still in my calculator. And I get that. Oh, it shouldn't be positive. So 1.5625. Sorry, try again. 1.5625 negative times 0.28, and I get that. So that comes out here. That's how I get it out of the bracket. Which means I can get rid of that large bracket now. And I just have to subtract it from 1. One easy trick is I can just add 1 here, and I get that. Helps if I actually take text. There we go. And that's the final answer, which means the vertex of this thing, what's my minimum cost in per hour in millions of dollars, where X is the number of items? Well, my minimum cost is to produce 1,250 items, because that 1.25 represents 1,000. And the millions of dollars it'll cost me is 500,000, because I have to multiply that second one by 1 million, because it's in millions of dollars. So you have to multiply your items by 1,000 and your min cost by 1 million, because in the question it says, is the cost per hour in millions of dollars? So the decimal represents $0.625 million. To get the actual number, you have to multiply by a million. And to get the actual number of items, because we're in thousands per item, you have to multiply by 1,000. So read the question carefully. This person's minimum cost, Vertex, will be to manufacture 1,250 items at a cost of $562,500 right there. If we put this into decimals, which also is a good habit to do, to avoid errors and to get maximum marks and to understand these things, we will also see that minimum point of 1.25, and they've rounded it up to 5.63. But you can see that this is not true if you make this f of x is equal to that, and you do f of 1.25. And you'll see it's actually 562.5. They just round it up visually. I think if we zoom in, they'll give us the more accurate one. There we go. So they just round up for visual point. But that's useful. And notice that if we also put it in vertex format, five, 6, 2, 5 was it? Something like that. We've got to square it. There we go. We get the same line because they're both the same line. Now, keep in mind, way back here, instead of using decimals, I could have also used this fraction I found out, minus 5 over 4. And that might have made things a little bit easier, because then I would discover that the number I have to subtract is the square of that, minus 25 over 16. Then I can just multiply this by its fraction, which is 28 over 100. And figure out what I have to subtract from the 1. You'll discover you get the same numbers, but some people prefer working with fractions. Your teacher, if you get a decimal that's too long, it's better to work with fractions for accuracy. And it depends what your teacher is asking, but ultimately when you read this question, the fractions don't matter. Okay, and so to continue, most of these are always just going to be finding the max or the min. So notice this one. Obviously, just read the question and try to understand what you're going for first. Clearly, this is an upward-facing parabola, and cannot be less than 1 means that y cannot be less than 1, which means that we're probably going to have a parabola that has a vertex that's above the y is equal to 1 line. Now, also notice, I want you to notice this. We're going to do the same method. We're going to factor out 3, and we're left with x squared minus 3x plus 5. This time I'm going to do the completing the square a little faster. I know that what I have to go for here is x minus 3.5 squared. Right away, instead of figuring out, oh, I'm going to have to subtract the 9 over 4, which is true, which by the way is 4.25. When I add that, I'm going to get, let's see, 2.25, which means I'm left with 3.75. So I'm pretty sure I'm going to be, times 3, sorry. So when I multiply this 9 minus 9 by 3, I'm going to be left with minus 27 over 4, which is roughly 5, 6, 6.25. So it can be less than 1. And when I add 5 to it, it's minus 1.5, which lends me to believe that the vertex is going to be this. 3.5 for x and negative 1.5. And I'm not 100% sure yet. So in other words, it can be less than 1. However, once I have this 3.5, or 3 over 2, which is 1.5. Oh, actually, can it? Let's see. Negative 1.5. It's going to be less, not minus 9 over 4, which is 2 and yeah, it can be. But notice that I figured out the x value of the vertex right here. It's 1.5. So if I take this original formula right here, and I put in 1.5 squared, I get 3 times what's 1.5 squared. 2.25 minus 6 times 1.5, which is 9, plus 5. So right here, minus 9 plus 5 is minus 4. And 3 times, I guess I was wrong, look at that, 3 times this is 6.75 minus 4, a y of equals 1.25. So I did my calculations wrong, which means that I just need the x value to plug into the equation to figure out the y value. And I'm going to let you in on one other hint. If you have it in standard form and you want to figure out the x value, you take b, in this case b is minus 6, and divide it by 2a, which is that. Oh, that's what I got wrong right there. That's why I got it wrong. When I factor out 3 here, this is minus 2x, which means this is x minus 1, which means the number I'm subtracting is minus 1. 3 times that makes 3, 1, plus 5, so we're really talking about 2. So anyway, if I take b divided by 2a, which in this case is minus 1 divided by 6, I get an x, so I did do the x wrong. I get an x is equal to minus 1. Now, that is going to be not the x value, that's going to be what the y-intercept is. And sorry, that's going to be the x factor. So x minus 1 would be the factor, which means x is equal to 1 at the vertex. So if I look at this and put it in here, 3 minus 6 minus 3 plus 5, it's 2. So I'm going to hit minus 1 comma 2. If you just put that into the, and that was a mess by the way, but if I put this into the Desmos, I can see that's true as well. Well, it's 1 comma 2, so I even did that one. 3, minus 6 plus 5 is 2. And that means I only needed the x value of the vertex. I only needed to factor out, and this time I'll factor it out properly. Get rid of all this junk. I only needed to factor out this part of it properly. So which means I move the 5 aside. I correctly this time factor out a 3. I get x squared minus 2, 2x. And I immediately know that the perfect square for that is x minus 1 squared. Now I figured out that x is equal to 1 for the vertex. I plug it back up in here. I get 3 minus 6, which is minus 3, plus 5, plus 2. And I immediately can rewrite my vertex formula. And this is called partially completing the square. Like this. And I figured it out. And you can also do it, as I said, sorry, what I failed to do was minus b over 2a will give you the x value. So minus b, which is minus 6, which is plus 6, over 2a, which is 6, gives me the x value as well. So it's minus b over 2a to get the x value. This comes from the quadratic equation, function equation, essentially. So keep that in mind. You can partially complete and still solve it. That was a long one for a simple question. But essentially, they just wanted you to find the vertex again. These are all just find the vertex. So if we look at this, the profit of this company in dollars is given with a downward-facing parabola, which means there's going to be a maximum profit somewhere, where x is the amount that's spent in advertising in $1,000 of dollars, so we have to multiply our x at the end by 1,000, but only at the end, and where the profit is also given, let's see, in thousands of dollars. So at the end we have to multiply our y by 1,000. But it's very much the same thing. So if you look at the first two numbers, we're going to put the minus 2,500 aside, and we're going to factor out a minus 5. And I get x squared minus 5 goes into 40 80 times minus 80x. So I forgot the x there. So it's clear that the square is going to be this. And if I square minus 40, it's clear I'm going to have to put a big bracket here and subtract 1,600. To get it out of the bracket, I'm going to have to multiply by 5 to get it out here, where it will become 5 times 1,600 is negative 1,600 is negative 8,000. Which means I can replace all of that. I'll just make a copy of this. With this. And then when I subtract this from it, I can replace both those. They add up to negative 80. Now I got to be careful here. Here's what I did wrong. This is a negative 5, so what comes out here is a plus 8,000. When I subtract that from it, I get 5,750. So my full thing ends up being minus 5, despite my butchering of it, 40 squared, plus the 5750. And if I'm going to answer the question, I must remember to multiply everything by 1,000. So the first question, determine the maximum profit. So that's going to be the y value of the vertex. And I have to multiply by 1,000. So it's going to be $5,000,000, $750,000. Determine the amount spent. That's going to be the x value, which is 40, but I have to multiply it by 1,000. So it's going to be $40,000 spent on advertising. And then what amount will be spent on advertising to obtain a profit of at least $4 million? So that's an excellent question. That means where's the profit of the $4 million? The profit's on the left side of the equation, which means I have to take the equation, and it's essentially equal to the profit, right? And I have to just replace the profit with whatever number they give me as the profit. And I have to solve it in reverse BEDMAS, which means first I have to subtract this. Now, keep in mind that the 40 million is in thousands of dollars, so we have to actually divide it by 1,000 to put it in terms, because all these are actually 5,750,000. So 4 million profit is what we're going for. So now I have to consider it as 4,000. When I subtract 5750 from both sides, it becomes negative 1750. When I divide that by 5, 5 goes into negative 5. Negative 5 goes into 17 3 times, goes into 25 5 times, and I end up with that. So that's after I divide both sides by negative 5. Now I've got to take a square root of it to get rid of the square root. There's going to be a negative value, but the negative value can be ignored because it's going to be, you can't spend negative dollars, but I have to take the square root of 350. And I get this long number, which we can see is not going to be that accurate. So I get x minus 40 is equal to this. And now, what's interesting is there's also another one, x minus 40 is equal to minus 18.708286. So we're going to keep that in mind. I have to add 40 to both sides. And this one I have to add 40 to both sides. So there is a second profit here. It depends, though. We'll have to see if it's possible. So when I add 40 to this side, it's going to be, and we might as well do it properly. So 350 square root. Make it negative and add 40. And I get this, 21, like this. So x is equal to that. So we can see these are the two possible x values to achieve a profit of $1 million. However, remember that all the x values have to be multiplied by 1,000. So we can spend $21,291.71, or we can spend $58,708.29. Which one would you rather spend? That. And that's the reason you get these two, is because in a parabola, we're going to find that value at two spots on the parabola, where y, if you set your y equals to 4,000, which is 4 million, you're going to find two spots here, one on the way up and one on the way down. So this cheaper amount here is on the way up, and this cheap other amount's on the way down. You'll see that if you graph it. So it was plus 400x minus 2550. So there we go. There's the graph. I'm going to set one value here at y is equal to 4,000. We're going to set the peak. We're going to try to see this graph a little bit more clearly by setting the y between 0 and, I don't know, 333? No, even more. Probably 5,505. Yeah, something like that. There it is. Oh, I forgot to square it right here. That's what's going on. There we go. Now look, there's the one on the way up. There's the one on the way down. Now I did a calculation error somewhere. So we'll have to go, oh, no I didn't. I did a typo error over here. There we go. There's the actual values. And we can see that we got them. Oh, I still did a calculation error somewhere. They're still off. So that means I should go back and just, before I do that, make sure I got the thing correct. And yes, I did, which means I did a calculation error. So now, just make sure that I've factored it correctly. Make sure this, you know what it is? That's not going to be, that's going to be negative. What's 40 squared? Times 5 times negative 5. 8,000. 5450. So that's probably the thing I got wrong. Let's see. Yeah. So I got 5750 when it should be this. So that's a great example of going too quickly. So when I subtract both sides, it's minus 1450 on the left. When I divide that by 5, minus 5, it goes in twice. And then 9 goes in 290. So this is when I divide both sides by 5. When I take the square root of that, I have to create a minus and a positive, which means x minus 40 is equal to this, and x minus 40 is equal to the negative version. And when I add 40 to both sides, this one's going to be 57.02938, which means, and rounds up to 39, which means I have to spend this much on advertising to achieve this. And this one is going to, and I've got to add 40, is going to be equal to this, and then times 10, times 100, there we go, is going to be equal to this in advertising. And let's see if I got that one correct. 22.9. Yeah, there we go. Those are the correct numbers. So you can see a small calculation error can screw up your answers. So go through it carefully. Let's look at number 12 here. So we're going to focus on the track. We're going to try to understand a couple things about the track before we address it. First of all, notice that the track has a short length here that's matched over here, and has a longer length over here that's also matched over here. Trying to build this new soccer field running track. The track coach wants 2 laps around the track to be 1,000 meters. So 2 laps. So if I go all the way around that, he wants twice to be 1,000 meters. Therefore, how much is 1 lap? 1 lap. 2 laps is equal to 1,000. Therefore, 1 lap is equal to 500 meters. He wants the rectangular infield area to be as large as possible. So that means he wants to maximize this area. Now I'm going to let you in on a little secret if we didn't have the end here. The maximum area you can ever achieve with a four-sided object is a square. If you don't have to use one side of it, it's generally twice as long as it is wide, but if you have to use all four sides, it's a square. Can both coaches be satisfied? Explain your answer. Well, since the integers large as possible, of course they can be satisfied. So that means I have to have a perimeter that is 500 meters. The perimeter of this is this length, half a circle, this length, and half a circle. Therefore, the perimeter, if I add up those two half circles, is equal to 2 times that red length, red line, plus the perimeter of a circle. And since I know I'm talking about 500 meters, I just don't know the red line, so we're going to call the red line x. And I just don't know the perimeter of the circle. I do know that the perimeter circle is based on pi, and I also know it's based on pi times the diameter, right? Pi times the diameter. See if you can, it's 2 pi r. See if you can spot the diameter in there. Well, that green line happens to be the exact diameter of that circle, which means the perimeter is going to be 2 times the x plus this value, which is 3.1415. Pi is just a number, but pi times y. But I also know that the diameter of that circle, let's see if we can figure it out. Oh, it's not x. Yeah, that's when we're adding it up, the perimeter. But he also wants x times y to be max. Right? Now, the question is, can I find a version of x that's equal to y? Let's see. Be 1,000 meters. The football coach wants the rectangle be as large as possible, and he wants it rectangle. Okay? Well, I know the area is going to be the inside, but we don't really know the area. Now, if the diameter is y, and this is also p times the diameter, there we go, I got it. And this is p times the diameter. If I rearrange this, and I divide both sides by 2, or I subtract 2x, that means this, which means the diameter is 500 divided is equal 500 minus 2x divided by pi. If that's the case, right, down below, I can substitute this d down here for this. That's the same as d, which means if I put brackets around it, this x has to multiply everything. And it's going to equal parabola. And then I should multiply everything by pi, or actually just leave it like that. So pi times d, yeah. And let's see. Yeah, pi is just a constant. So I can pretty much ignore pi, but we'll see it when we do it. If I separate that pi into two different things, I get x is going to be multiplied to 500 divided by pi minus 2x squared, which is also divided by pi. So if I put it another way, it's 2 divided by pi x squared. And it's just 500 divided by pi times x is equal to area, or y. So if I put this in fractions, I'm left with something like that looks like this. So that's just a number multiplying my x squared. Also keep in mind my x squared is there. So rearranging that, I want my minus 2 over pi x squared up front. And it's going to be plus that. Well, you do the same thing. I don't want anything in front of my x squared. So I'm going to divide both things by minus. I'm going to factor out minus 2 over pi. It's not going to be that big of a deal. I'm going to be left with x squared. And how do you divide a fraction by another fraction? Right? You should know this for any fractions. So how do I divide this fraction by that fraction? Well, the secret is you keep the numerator fraction the same, and you simply multiply that numerator fraction by the reciprocal of the bottom one, and you can put the minus up top. Doesn't matter where the minus goes. Like this. I can see immediately these cancel out, and that leaves minus 1. 500 times minus 1 divided by 2. It's clear that's negative 250, which means when I factor out minus 2 over pi, I'm left with x squared minus 250x. Keep in mind that first x squared is that. And I don't even have to touch, there's no number here. So all I have to do is figure out what the perfect square is. All right, so this is clearly the equation I'm working with, and keep in mind that thing right here is squared. If I'm going to find the perfect square of that, it's going to be x minus 125. If I expand the perfect square of that, I get x squared minus 250x, and then I just got to find out what minus 125 squared is. It's the same as positive 125 squared. It's this. Like that. But this is the only part I want from it. So that means I'm going to have to subtract this on this side in order to get what I want. There we go. And keep in mind that's squared, and keep in mind the outside of this is squared. Which means up above, I can replace all of this with this. But don't get carried away. When I did this, I was supposed to include a big old bracket like this so that I would not forget to multiply it, this final number, to get it out of the bracket, this number out of the bracket, by multiplying by that. So I'm going to take this, it's going to be negative, I'm going to multiply it by negative 2, and I can pretty much leave it as a fraction of pi. You really don't want to put it, you don't really want to change it. So it's going to be this over pi. So we're going to get the max values, the area of this thing is going to be, that's going to be the max value of it. And the x value that I should use, yeah, this will disappear now. And the x value I should use is 125. Well, I can go back here to figure out my x, because my x times y is here, but I also have an equation right here to figure out that y diameter. So that means my x value of the track is going to be 125 meters long, which means up here is 125, and down here is 125. That's 250, which means the perimeter of this circle over here is also 125, and the perimeter of this circle is also 125, which satisfies 500 meters if I go around it. I just got to figure out what this square is now, right? Well, the diameter of this square is going to be equal, we already know. Now that I know x, the diameter there, or the area of that, the perimeter of that circle, is going to be equal to pi times the diameter. Well, I know the perimeter is 250. Let's go to pi diameter. So the diameter, the y value of this thing is going to be 250 over pi. Now you could answer that just like that, but if you do want to know what 250 over pi is, it's going to be this. Oh, you got to hit equals. Which means my y value or diameter, is going to be equal to this many meters, which means this green part here is 79.57. To confirm that, multiply 125 by 79.57 and see if you get this y value. Let's see here. 79.57 times 125 is equal to that. Now we just got to see if that multiplied by pi is going to equal to the 31,250. And it does. I mean, there's some rounding errors because I didn't use the full decimal here. But yeah. So now if I were to graph this, was it 31,250? There we go. So if I were to graph it, that's what it would look like. And don't forget, you've got to always put a square here. Otherwise you don't get a parabola. And that's going to be the max value. And there you can see the max area of the square, which is what our focus was. And this value of this square happens to be what 31,250 divided by pi comes out to. We can see this by making f of 125 here. And there we get our max value right there. So you can see these things you can figure out if you're given two possible equations, you can figure out two missing variables. All right, let's look at this question. Which method would I use? Compare the method of finding max or min values of the quadratic function. Give a reason for your answer. Okay, so would I min-max value of the quadratic function? So would I use completing the square here? Would I factor it? So if I factor out a 3, they don't have 3 in common. So I could look to see if there's possible factors. If I multiply 3 times 2, I get 6 and minus 7. So it's clear to me that these basic factors, before I group it, here's a little trick, by the way, are x minus 1. And I'm not allowed to do this when there's a number in front of the x squared. X minus 6. And if I look at the leading coefficient here, this is a little trick that I like myself. It's 3 if I divide both these by 3. What's 6 divided by 3? It clearly divides easily. It's 2. And it's clear that I cannot divide 1 by 3 easily at all. So I'm instead going to move this in front. You've now discovered the factors of the circle, or of this equation. Just to verify, 3 times x, 3x squared. 3x times minus 2 is minus 6x, and minus 1x is minus 7x. And minus 1 times minus 2 is plus 2. I actually like this method. So I can see that there's pretty easy factors, which means the coordinates of the two x-intercepts are x is equal to a third and x is equal to 2. Now the problem with this is I'm clearly dealing with, it's hard to find the actual middle point, but if I add 2 plus a third and divide it by 2, so how do I add 2 plus a third? It's 6 over 3 plus 1 over 3, 7 over 3. And here's a secret about dividing a fraction by 2, just double the denominator. So that means the axis of symmetry here is 7 over 6. And I could just plug 7 over 6 into this equation, but you can see that it's going to get lots of fractions. So let's see if completing the square would be easier. And we can see the problem here is you get left with an odd number as well. But when I take 3 out, I get, how many times does it go in there? 2 point, and that's a problem. It's 2 1/3 again. Or if you want, 2.33333333. squared, x rather, first one squared, and then plus 2 way over here. Like that. If I find the perfect square of that, I'd have to half that, which is negative 1.16666666, like that. Then I'd have to find the square of that. So first let's confirm that 2.3 half is 1.66666. And I get that, and it is. And when I multiply it by this, it's that, and it's going to be negative. And then when I multiply it by 3, it's going to be that. And then when I add 2, it's going to be that. So if I'm working with decimals, that's fine. Do I find either one easier? Well, let's see what happens when we plug this. I think they're both hard. The factor starts off nice, and I guess I could just keep it in. Let's try keeping it in fractions. So 7 over 6 squared is 49 over 36. Then minus 7 times 7 over 6 is minus 49 over 6 plus 2. So I got a lot of fractions. But the 3 goes into the 36 here. 12. So I can replace this with a big old 12. So it's not hellish. And I'll just keep this aside. It's not hellish because I can now multiply this by 2. And I get 49 minus 98. And what's 2 times 12? Plus 24 all over 12. So if I do this, I get minus 49 here, plus 24. If I take off 4 there, and 2 there, I get minus 25 over 12. So I get an x of this. The x is, I think I found it was 7 over 6. And that is the midpoint. So I've got a slightly, no, I've got the same values. So let's just see if minus 25 over 12 is indeed negative 2.008. Yeah, I don't know. I kind of like the fractions better just because I'm pretty comfortable adding fractions. You've got to make all the denominators 12. So for this one, you've got to turn it into 24 over 12. And for this one, you've got to double it, 108 over 12. At that point, you can add all the numerators, and you get minus 25 over 12. I don't know. The fractions was a little bit easier. I could have worked in fractions up here as well. I would have been working as 7 over 6 here, and then subtracting 49 over 36, and then adding 2 to it. They're about the same. Hard to say. Rock is thrown straight up in the air from an initial height. I don't always answer the extending, by the way. So it's from a height with an initial velocity v, meters per second. The height above the ground after 2 seconds is based on time and velocity and height. Find an expression for the time it takes for the rock to reach maximum height. Okay, so maximum height will be a completion of square of this without any numbers, and the x value will be velocity, and the y value will be height, I think. Let's see, yeah, height will be the final y value, and velocity will be the x value. No, time will be the x value. So if I just work on that, I have to first take 4.9 out of both, and I get t squared plus velocity divided by 4.9, essentially. times time, and that's a t squared here. So it's going to be velocity as a fraction over minus 4.9. That's because when you factor out, and I'm going to put HO way over here. That's because when you factor out something, you're essentially dividing it by that thing both times. So that's what I have so far. To half a fraction, if I want to divide that fraction by 2, just double the bottom. And now notice it's approaching the speed of gravity of 9.8. So to get this, oh, by the way, this is a minus up here because I factored out a negative. So this is actually a minus, because the negative 4.9 goes to the top instead. So when I factor out this, or divide it by 2, I'm left with velocity over 9.8. Notice that's starting to look a lot like gravity, because velocity divided by acceleration of gravity will give you time. And then if I'm going to subtract that, I have to square it and subtract it. So it's v squared over 9.8 squared. Squared. Both squared. To get it outside of the giant brackets, I have to multiply it by 4.9. So I'm going to get negative 4.9. So I'm going to get plus 4.9 times v squared divided by 9.8 squared, because nothing happened to it, plus height. And you're going to discover these are all going to be sort of physics questions related to physics. So I'm going to be left with this. Height of t is equal to minus 4.9. Curious if I went the right way here. T minus velocity initial divided by 9.8 plus, and I'd have to add these, I'd have to, I wonder if I can, if 9.8 squared is easily dividable by 4.9. 19.6. Weird. So this becomes 19.6. Velocity squared plus height. Which means the maximum of this parabola the time that it takes to reach that max height is initial velocity divided by 9.8, and the max height it reaches is 9.6 times velocity squared plus the initial height. Now, I don't know if that's the, I'm pretty sure that's what they were looking for. I might have done a little weirdness because, no, I think I got it right. I'm curious what the book says, so I'm going to come back to that. It's probably related to some physics questions. Okay, school dance is $8, usually $110. Before you continue, ask yourself how much money you make, how much money or income or whatever, revenue, is achieved when 800 students spend 800 bucks. How would you figure that out? You'd take 8 and you'd multiply by 300, right? So you know their normal revenue is that. So just keep that in mind. That's their normal revenue. We'll put it up here. And how do we figure out the revenue of anything? We take the price of it and we multiply by the number of people who bought it. But then they know for every dollar increase in the price of the ticket, 30 fewer people will attend. Which means if I increase my $8 by $1 X or X, I'm also going to lose 300 people, 30 people, times each one of those X value dollars I increase it. And that will be my profit, my revenue, I should say, not profit. What price will maximize the revenue? In other words, how much can I increase this price to get where I want? And obviously this is going to create a downward facing parabola. What's 8 times 300? There's that 2400. What's 8 times 30x? Minus 240x. What's x times 300? Plus 300x. What's x times minus 30? Minus 30x squared is equal to revenue. Notice that I can add up the values in the middle. I'm just going to rearrange it, by the way. Minus 30x squared. What do those values add up in the middle? 60x plus 2400, like that. Also notice that I can factor out a minus 30 from everything. But I'm just going to factor out from the first two terms. I get x squared. Minus 30 out of 60x becomes minus 2x. And then I'm going to leave my 2400 over here. And just remember to put an x squared. It's clear to me that my perfect square there is going to be x minus 1 squared. It's also clear to me that I have to put a little big bracket, and that the number I have to subtract is the square of minus 1. And put it all in a big bracket. And then don't forget that this plus 2400 is hanging out and waiting. To get that minus 1 out of the big bracket, I have to multiply it by minus 30 to get it here, which means that minus 1 times minus 30 becomes plus 30. There we go. Plus 30, which means plus 30 plus 240, 2400 is plus 2430. So I can see that I cannot increase the tickets very much. And you might say, how much can we increase the tickets? Well, the vertex of this, and it's clearly facing downwards, is this. Which means, if I go back to my original equation right here, x plus 8 plus x, well, 8 plus x, in this case, x is $1, x is 1, in my max value of the vertex, which means my price is 8 plus x, which is 8 plus 1, so $9 is my maximum value. And the max profit I'll get from that is $2,430, which also means the number of people who attend are 300 minus 30x, and x in this case is 1, which is 300 minus 30, so that means 270 people attend. So that was the best case scenario. Now we can see this, and what's interesting about this is when you put it into Desmos, put it in the factored form that I came up with, 8 plus x, or rather the formula for changing things, and you're going to get this parabola that has the exact max values that we just found. But also notice that when we expand it, we will also get the exact same parabola that we just found. And also notice when we put it in vertex format, we will also get the exact same graph that we just found. So this is standard format. That's not quite factored format. Well, you know what? It is. Because when x is 10, yeah, there it is. And when x is minus 8, which means, what are those values, by the way? 10 and minus 8. Well, that's this point where you start making less than $0. That's called the break-even point. So if I sell my tickets for more than 10x, so 8 plus 10, if I sell my tickets for more than $18, I start losing money. If I sell my tickets for anything less than 8 plus 10, $18, I'm making money. And even here, so this was how I first used to run my dances. This is the best case scenario. But even here, I'm still making money. How do I subtract 2 from $8? It's $6 until I reach, of course, $8, where I'm charging nothing. So if I'm charging $0, because it's x plus minus 8, 0, I'm, of course, cannot make money. So I'm making money as long as I'm charging more than $0 and less than $18. And my best case scenario is to charge 8 plus $1, $9, and that'll give me a revenue of $2,430, but it'll also mean I'll only have 270 people in the gym. Those questions do that every time. Now I'm curious, you can stop now, but I'm going to just zip down and see what the answer for this was, 14, and see if I did it correctly. So it's page 154, number 14. Ah, okay, they just wanted the x value. So sure enough, although and I put it squared, that was the number I was subtracting. But indeed, that's the time value that we would have achieved. So that's true. I should have figured out that they just wanted the time value, VO over 9.8, which was what we got. I don't know if I kept it. I don't think I did. Yeah, there it is. So that makes sense because on this graph, if you look at it, the height is always on the left side is always the y-axis. So this is the height based on time. That's what that means. And the x value you can see over and over again is time. So the max height of this downward facing parabola is velocity, initial velocity divided by 9.8. So you might say, well, that's not a time unit. And I mean, you'd be right in a way. But that's how we would come up with our time. And so it would really probably be divided by 9.8 meters. Probably per second squared, actually. Because if I take velocity, which is meters per second, so treat it like a fraction, and I divide it by my acceleration, meters per second squared, I'm actually taking this and multiplying it by the reciprocal of that, which is second squared over meters. And we can see the meters cancel out and all but one of the times cancel out, leaving 1 second. So that's in the value of meters per second squared, which is gravity, which makes sense. There you go.